Hubble Space Telescope. The Hubble Space Telescope, launched on April 24, 1990, carried into orbit by the Space Shuttle Discovery, a telescope the size of a school bus floating 340 miles above Earth, free from atmospheric distortion. Early on, a mirror flaw caused blurry images, briefly making it a symbol of expensive failure. But in 1993, astronauts flew up and fixed it. After that repair, Hubble performed beyond almost anyone's expectations. It captured the deepest images of space ever taken, revealing thousands of galaxies in a patch of sky no larger than a grain of sand held at arm's length. It confirmed the universe is expanding at an accelerating rate, a discovery that earned the Nobel Prize in 2011. Even after 3 decades, Hubble continues to observe. Few instruments in history have done more to reshape our understanding of the cosmos. James Webb Space Telescope. The James Webb Space Telescope launched on December 25, 2021, after decades of planning and one of the most complex engineering challenges ever undertaken. Webb is not a replacement for Hubble. It's something different entirely. While Hubble sees invisible light, Webb observes in infrared, detecting heat rather than light. This matters because the most distant objects have had their light stretched by the expansion of space into the infrared range our eyes can't see. Webb's mirror is nearly 6.5 meters across, made of 18 gold-coated segments that unfolded in space like a flower, paired with a sun shield the size of a tennis court. It can peer back over 13 billion years to the first galaxies forming after the Big Bang, analyze exoplanet atmospheres for signs of life, and see through cosmic dust to reveal star-forming nurseries. It has only just begun its work. Spitzer Space Telescope. The Spitzer Space Telescope launched in 2003 and operated for nearly 17 years before retiring in January 2020. Like Webb, its specialty was infrared astronomy, seeing through dust and gas that blocks visible light. Spitzer studied star-forming regions, distant galaxies, and exoplanets, even mapping temperature variations across a planet's surface. It discovered a previously unknown ring around Saturn, so large and diffuse it had gone undetected for centuries. Its most lasting contribution may be the data it gathered on the TRAPPIST-1 system, 7 Earth-sized planets orbiting a single star, 3 in the zone where liquid water could exist. Spitzer wasn't the most powerful telescope of its time, but it asked questions others couldn't and answered them with quiet precision. Chandra X-ray Observatory. The Chandra X-ray Observatory launched in 1999 and has studied the universe in X-ray light ever since. X-rays are produced by matter at extreme temperatures, millions of degrees, so Chandra observes the most violent environments in the universe: exploded star remnants, hot gas between galaxies, and material spiraling into black holes. Because Earth's atmosphere absorbs X-rays completely, this kind of telescope can only work in space. Chandra's revolution is sharp enough to detect sources the size of a coin seen from 12 miles away. Over the years, it has helped scientists understand how black holes grow, how elements forged in supernovae spread across galaxies, and how the universe's largest structures formed. It remains one of NASA's most productive missions. Kepler Space Telescope. Kepler launched in 2009 with one focused mission: find out how common planets are around other stars. Kepler stared at a single patch of sky, monitoring 150,000 stars simultaneously for tiny dips in brightness caused by a planet passing in front. Over nearly a decade, it confirmed more than 2,600 exoplanets. What emerged was a fundamental shift in astronomy. Planets are not rare. They are everywhere. Most stars have at least one. Rocky, Earth-sized planets are found throughout the galaxy. Kepler also revealed that many planetary systems look nothing like ours. Giant planets orbiting in days, multiple worlds packed closer than Mercury is to the Sun. When it ran out of fuel in 2018, the question had changed, not whether planets exist around other stars, but what those planets are actually like. TESS, the Transiting Exoplanet Survey satellite, launched in 2018 and picked up where Kepler left off, but with a different approach. Instead of staring at one region, TESS surveys almost the entire sky, focusing on bright, nearby stars. That proximity matters. When TESS finds a planet, the star is close enough that powerful telescopes like Webb can follow up and study it in detail. In its first few years, TESS confirmed hundreds of exoplanets and flagged thousands more. It also contributed beyond planet hunting, tracking stellar flares, pulsating stars, and early light from supernovae. TESS represents a different philosophy: cast a wide net across the whole sky, then hand the best finds to other telescopes for a closer look. Gaia is a European Space Agency mission launched in December 2013 with a goal deceptively simple in concept but staggering in execution: map the Milky Way in 3 dimensions with unprecedented precision. Gaia measures the positions, distances, and motions of billions of stars, producing the most detailed map of our galaxy ever made. By tracking tiny shifts in stellar positions as it orbits, it calculates distances with extraordinary accuracy and reveals how stars move through the galaxy. That data tells us the Milky Way's history, ancient streams of stars from dwarf galaxies absorbed long ago, groups of stars born together that have since drifted apart. Gaia doesn't take dramatic images, it produces a precise atlas of our cosmic neighborhood, and that atlas is still reshaping astrophysics. Fermi Gamma-ray Space Telescope. The Fermi Gamma-ray Space Telescope launched in 2008 to study the most energetic light in the universe. Gamma rays are produced by the most extreme events imaginable: collapsing stars, merging neutron stars, jets from active galaxies, and gamma-ray bursts that can release more energy in seconds than the Sun will produce in its entire lifetime. Fermi has detected thousands of these bursts. It has cataloged pulsars, mapped gamma-ray emission across the sky, and observed jets from supermassive black holes. It has also contributed to the search for dark matter, testing theories that predict annihilating dark matter particles would produce gamma rays. Fermi watches the entire sky simultaneously, providing a continuous view of the high-energy universe. WISE, the Wide Field Infrared Survey Explorer, launched in December 2009 with a clear mandate: scan the entire sky in infrared and catalog everything. In roughly 10 months, it surveyed hundreds of millions of objects, discovering more than 33,000 asteroids, hundreds of cold brown dwarfs, and millions of distant galaxies. After its primary mission ended, it was reactivated as NEO-WISE in 2013, focused on tracking near-Earth asteroids and becoming one of the most productive asteroid hunting missions in history. The original WISE survey remains a foundational reference that astronomers still mine for new discoveries today. Nancy Grace Roman Space Telescope. Nancy Grace Roman Space Telescope is NASA's next flagship observatory, expected to launch in the late 2020s, named after NASA's first chief of astronomy and a key figure behind Hubble. Roman is designed to see wide. Where Hubble and Webb zoom in on small areas with great detail, Roman will survey enormous swaths of sky with comparable sharpness, a field of view 100 times larger than Hubble's. It will study dark energy by mapping hundreds of millions of galaxies, search for exoplanets through gravitational microlensing, including free-floating planets the transit method can't find, and create an infrared map to complement Webb's close-up images. Roman is the next chapter in the story Hubble began, not zooming in further, but pulling back to finally see the full picture.